Hi all, welcome to Engineers Think Box. This is Sharu. So in this video we'll see a problem on circular convolution using DFT and IDFT approach. So the question here is compute the circular convolution of the sequences x1 of n is equal to 1, 1, 2, 1 and x2 of n is equal to 1, 2, 3, 4 using DFT and IDFT approach. So before getting into the problem, I would like to recollect these two steps, that is circular convolution property. The convolution property of DFT states that DFT of circular convolution of two sequences is equivalent to the product of their individual DFTs. That is, DFT of circular convolution is in time domain is the multiplication in frequency domain. So this is what circular convolution property is all about. Next, we are going to see the formula for solving DFT and IDFT using matrix method. So here DFT is the process of converting from time domain x of n to frequency domain x of k. So x of k is equal to twiddle factor matrix multiplied by x of n as the formula. Coming to IDFT, IDFT is the process of converting from frequency domain to time domain, that is the inverse process. So here the formula is x of n is equal to 1 by n twiddle factor matrix multiplied by x of k. So these are the twiddle factor matrices in both the cases. So now coming to the question, here they have given two sequences, right? So in the flow of question will be like, initially we will be converting this x1 of n to x1 of k and this x2 of n to x2 of k, and we will be multiplying this both, that is x1 of k multiplied by x2 of k, which is equal to y of k. Now this y of k will be finally converted to y of n. So this is the whole sequence. So this it involves 4 steps. Step 1 will step 2 and step 3 and finally step 4. Okay, so let's get into the problem. Once if we get into the problem, it will be much more clear. Step 1. First we are going to convert this x1 of n to x1 of k using DFT matrix method. So the formula for it, that is twiddle factor matrix multiplied by x of n. So this is the twiddle factor matrix multiplied by x of n in the column. So here x1 of n is 1, 1, 2, 1. Those values I have entered here. Now normal matrix multiplication. 1 into 1, 1, 1 into 1, 1, plus 1 into 2, 2, plus 1 into 1, 1. Okay, now here 1 into 1 is 1, minus j into 1 is minus j, minus 1 into 2 is minus 2, j into 1 is plus j. 1 into 1 is 1, minus 1 into 1 is minus 1, 1 into 2 is 2, plus 2, and minus 1 into 1 is minus 1. Finally, 1 into 1 is 1. This will be like j into 1 is plus j, minus 1 into 2 is minus 2, minus j into 1 is minus j. So this is how I got this. Now I am going to simplify this. This will be like 1 plus 1 plus 2 plus 1, that is 5. Here minus j and plus j will be cancelled. So it will be like 1 minus 2 is minus 1. Here if I simplify this, this plus 1 and minus 1 will get cancelled. So 2 minus 1 is 1. Here this plus j and minus j will get cancelled. This 1 minus 2 is minus 1. So this is the value x1 of k. This is the step 1 where we have converted this x1 of n, that is from the time domain to the frequency domain x1 of k. In the next step, step 2, I am going to convert this x2 of n to x2 of k. So for that, same twiddle factor matrix, the formula for converting DFT using twiddle factor matrix is x of k is equal to twiddle factor matrix multiplied by x of n. This is the formula which we have seen in the first slide. So now twiddle factor matrix is this, and the x of n is that is x2 of n is 1, 2, 3, 4. Now normal matrix multiplication again. 1 into 1 is 1, plus 1 into 2 is 2, plus 1 into 3 is 3, plus 1 into 4 is 4. Here 1 into 1 is 1, minus j into 2 is minus 2j, minus 1 into 3 is minus 3, j into 4 is 4j, plus 4j. Now here 1 into 1 is 1, minus 1 into 2 is minus 2, 1 into 3 is plus 3, minus 1 into 4 is minus 4. Finally, this row 1 into 1 is 1, j into 2 is plus 2j, minus 1 into 3 is minus 3, minus j into 4 is minus 4j. Now I am going to simplify this. 1 plus 2 plus 3 plus 4 is 10. Here it will be like 1 minus you will be dealing with imaginary values and real values separately. So 1 minus 3 will be minus 2 and this minus 2j and plus 4j. If we are going to solve, we will be ending up like plus 2j. Now here if we solve this 1 minus 2 plus 3 minus 4 minus 2, and similarly here we will be solving this 1 minus 3 first, that is minus 2, and 2j minus 4j, that is minus 2j. So this is the formula. This is the final x2 of k. Now we have converted x2 of n from time domain to x2 of k to frequency domain. Now step 3, we know the convolution property is DFT of circular convolution in time domain. Circular convolution in time domain is equal to multiplication, that is the product in frequency domain. Yes. So now we have we know the value of x1 of k and x2 of k. That is, we have solved it in the previous steps. In step 1 we have received x1 of k value. In step 2 I have received x2 of k value. Now I am going to multiply this both value, normal multiplication. 5 tens are 50. And the next step we are going to multiply minus 1 into minus 2 plus 2j. That is minus 1 into minus 2 is 2. 1 into 2j is 2j. Minus into plus is minus. So 2 minus 2j is the answer. Now 1 minus 2, 1 into minus 2 is minus 2, and at last minus 1 into minus 2 minus 2j. Similarly, minus 1 will be multiplied by both the terms. 1 into 2 is 2, minus into minus is plus, and 1 into 2j is 2j, minus into minus is plus. So 2 plus 2j is the answer. So now we have got the answer for y of k. In the final step, we will be converting this y of k to y of n, for which we will be using IDFT formula using matrix method. The formula is x of n is equal to 1 by 4 of twiddle factor matrix into x of k. So 1 by 4 into twiddle factor matrix, that is for IDFT things, and multiplied by y of k. Y of k is 50, 2 minus 2j minus 2, 2 plus 2j. 50, 2 minus 2j minus 2, 2 plus 2j. Okay. Now normal multiplication again. 1 into 50 is 50. 1 into 2 minus 2j is 2 minus 2j. 1 into minus 2 is minus 2. 1 into 2 plus 2j is 2 plus 2j. The next step, 1 into 50 is 1 into 50. J into 2 minus 2j, that is j into 2 minus 2j will be like 2j minus 2j square. That is what is written here. And minus 1 into minus 2 is plus 2, minus j into 2 plus 2j. So now minus j into 2 plus 2j. It will be like minus 2j minus 2j square. So that is what is written here. Minus 2j square. Now third row. 1 into 50 is 50. minus 1 into 2 minus 2j. Minus 1 into 2 minus 2j. It will be like minus 2 plus 2j. So that is what is written here. And 1 into minus 2 is minus 2. Minus 1 into 2 plus 2j. So minus 1 into 2 plus 2j. It will be like 2 minus 2 minus 2j. That is what is here. Now finally last row, 50, 1 into 50 is 50, and minus j into 2 minus 2j. So it will be like minus 2j, minus into minus is plus 2j square. So minus 2j plus 2j square is present here. Now 1 into minus 2 is minus 2, and this is actually minus 2 here. I have made a mistake. And finally j into 2 plus 2j. J into 2 plus 2j is 2j plus 2j square. That is what is written here. Okay, so it's just normal matrix multiplication. You have to be careful while multiplying. So now I am going to solve this using calculator. Or you can also solve manually, but if you are going to use calculator, you will not make any mistakes. So set your calculator in the complex mode, and you will be inputting terms like 50 plus 2 minus 2. Since j will not be present in the calculator, if you press the term e and g in the calculator, you will end up with I, for which the calculator should be in complex mode. Keep it in mind. And minus 2 plus 2 plus 2i. This is the stuff which you have to insert in your calculator. You will end up with direct answer like 52. For the next thing, you will be entering like 50 plus 2i minus 2i square plus 2 minus 2i minus 2i square. That was 56. For this, you will be entering like 50 minus 2 plus 2i minus 2 minus 2 minus 2i, which is equal to 44. Finally, 50 minus 2i plus 2i square minus 2 plus 2i plus 2i square, which is equal to 48. If you are going to solve manually, remember the value of j square is minus 1. That is, the value of j is root of minus 1. So if you are going to square on both sides, it will be like root of minus 1 the whole square. So j square value is minus 1. Now after this step, there is 1 by 4 outside, which you should not forget. So you will be taking this 1 by 4 inside for each term. So after solving it, you will end up like y of n is equal to 13, 14, 11 and 12. So now I would like to recollect the steps. Firstly, we will be converting this x of 1 to x of k using DFT matrix method. Next, this x2 of n to x2 of k using DFT matrix method. Then we will be multiplying this both. x1 of k multiplied by x2 of k, which is equal to y of k. This y of k will be converted to y of n using IDFT matrix method. Okay. So 4 steps are involved here. First step will be conversion from x1 of n to x1 of k. Second step is x2 of n to x2 of k. Third step is you will be multiplying this both, and finally in fourth step you will be converting this y of k to y of n using IDFT matrix method. So this is all about the circular convolution using DFT and IDFT approach. Thank you.